In this problem, we are given the following circuit diagram here. We are asked to find the equivalent capacitance with respect to terminals A and B. So we are going to do that first. It's going to be in microfarad, so we don't need to convert anything with units. After this, we need to find the initial voltage across the equivalent capacitance. Before we do any of this, we should write out what a normal capacitor looks like. We have one end like this, our line, then we kind of have this pipe, and then a parenthesis looking part, a line, and then our other node right here. Now this is what a normal capacitor looks like, because normally current is flowing in this direction, and then normally our voltage is going in this direction. Remember, voltage drop is from the positive to the negative, or the voltage goes into the positive and out of the negative. As long as our current and our voltage are in the same direction, that means we will have a positive. If our current is in a different direction, it'll be a negative. But before we deal with any of that voltage stuff, we're going to find the equivalent capacitance for this. Well, for equivalent capacitance, we know if they're in parallel, all we need to do is add them together. If they are in series, we have to do the parallel formula for resistors, kind of the 1 over the first capacitor plus 1 over the next capacitor, and then all raised to the negative first power. So we're going to get into it by looking at the far right side first. We can see that our 4 microfarad and our 6 microfarad capacitor are in series. That means we are going to have to put them in the 1 over the capacitor plus 1 over the next capacitor formula raised to the negative first power, and this is going to give us 2.4. We can see that this 2.4 is going to be in parallel with our 1.6 microfarad capacitor. So we can just add them together, and we are going to get 4. Now, the 4 microfarad capacitor is in series with this 12 microfarad capacitor. So now we have to do the in parallel formula, and this is going to give us 3. This 3 is in parallel with this 5 microfarad capacitor, so we can just add them together, and then we are going to get 8. Now that we have 8, we are just going to say that this microfarad capacitor is equal to 8, and then there's basically nothing on this side. It's kind of the equivalent to it. Before we do the next part, we are going to look at these two capacitors that are together. Once we have this, we are going to see that this capacitor is in series with this, so we are going to do the series formula. But our 8 microfarad capacitor and our 16 microfarad capacitor are in parallel up top. Remember, if they are in parallel and if they are capacitors, we just add them together. So we are going to have a 16 plus 8, which will give us a 24. Now our 24 and our 8 microfarad capacitor equivalents are in series. So we have to do that formula where it's 1 over the first capacitor plus 1 over the next capacitor. The order doesn't really matter. Raised to the negative first power, and this is going to give us 6. So we have 6 microfarads as our answer. Now we're going to look at the initial voltage for this. Well, to look at initial voltage, we're going to start on the far right side with this 15 volts and this 3 volts. We know that voltage drop is from the positive to the negative, so we're going positive to negative, and we're going positive to negative. We can see that our voltages are kind of colliding against each other. That means we're going to have to subtract one of them. Well, when we look at our 15 volts right here, we know that it looks the same as the picture right here. So our 15 volts should be positive. We will have a 15 and then a plus negative 3. This should be equal to 12, because if we look at our 3 volts, we can see that it is opposite of the diagram that we have up here as well. Since we have 12 volts here, we know that our 1.6 microfarad is going to be 12 volts as well, because it's in parallel. And remember that voltages in parallel are the same. Now, this voltage in parallel, since our 12 volts is a positive, has to be a plus minus like this. And our voltage is going into the positive out of the negative. And if we draw the same thing for this 5 volt right here, into the positive out of the negative, we can see that they're again in conflict with each other. That means one of them has to subtract. And even though both of these look exactly like this drawing, we know that our 12 volts is positive, so that means our 5 volts has to be negative. So we are going to subtract 5 from our 12, and we're going to get 7 volts. Now we have 7 volts. Our 15 microfarad right here is in parallel with this, so this is the equivalent to 7 volts here. Now for our 8 microfarad and our 16 microfarad, these are in parallel, so that means our 16 microfarad is going to have 10 volts. However, if we look at this, how the capacitor is written out with the plus and minus, we can see that we're going to actually have a negative 10 volts. So our 16 microfarads is going to be negative 10 volts. Now if we draw our 7 volts, if we draw the actual plus minus here, and then for our negative 10 volts, if we draw the plus minus here, we can see that if we go into the positive like this and out of the negative and into the positive and out of the negative for our 7 volts, we're just going to add them together. So if we come in here and we have a minus 10 plus 7, we get negative 3. So that means our initial voltage is going to be negative 3 volts. And that's how you would go about solving this problem. If you want more intro to circuit analysis, as well as capacitance, voltage, and inductors, there's a playlist and notes in the description below. If you have any questions about this material, feel free to leave them in the comments as well.